Scientists can't explain 3I Atlas. Is it really an alien ship? Sounds impossible, right? But it's not. It's happening right now. Discovered on the 1st of July 2025 by the Atlas telescope in Chile. Confirmed interstellar just a day later. It's racing through our solar system at 210,000 kilometers per hour. Too bright for its distance. Too perfect in its orbit. It brushes past Mars on October 3, disappears behind the Sun on October 29, right when no one can track it. NASA says, comet. Harvard says, ? In this video, we reveal what's really happening and why 3I Atlas may be the strangest visitor our skies have ever seen. Before we begin, feel free to let us know in the comments what time it is for you and where you're listening from. We love staying connected with our community. Now, it's time to close your eyes. Let's begin. You think space is predictable. It isn't. It's chaos wrapped in math, and sometimes that math breaks. The 1st of July 2025. A lonely telescope in Chile picks up a whisper of light, faint, cold, almost nothing. Then the motion data drops and every alarm starts ringing. The thing isn't orbiting the Sunday, it's flying through. Straight line, no leash. Within hours, the Minor Planet Center confirms it. The third interstellar visitor ever recorded, 3I Atlas. The 3 for third, the I for interstellar, the Atlas for the survey that caught it. Now, here's where it gets wild. Its path isn't random. It's almost perfectly level with the planets, just 5 degrees off the ecliptic plane. That's the solar system's main highway. Comets from other stars shouldn't know it exists. But 3I Atlas slides right along it, calm as if it's following a lane that was always there. Then the brightness hits. Too strong. Too soon. If sunlight alone made it glow that much, the nucleus would have to be 20 kilometers wide, a floating mountain. The chance of us spotting that giant first? 0.0001. But it gets stranger. Every time telescopes check again, the numbers hold. The orbit stays clean, the light stays bright, and the probability keeps screaming no way. NASA calls it a fascinating natural comet. Harvard calls it statistically absurd. And the rest of us? We start asking the question no one wants on record. Is this thing traveling through our system? Or through our expectations? Because when something crosses light years only to trace our planetary plane with perfect grace, coincidence starts sounding a lot like choreography. And that's the moment scientists stop describing and start watching. You think science kills mystery. It feeds on it. Especially when the numbers refuse to sit still. Within a week, 3I Atlas had the astronomy world split in half. On one side, NASA, calm, methodical, calling it another comet. On the other, Avi Loeb, the Harvard physicist who never blinks at controversy. The man who once said Oumuamua might have been technology, not rock. Now, here's where the tension starts. Loeb looks at the early data and sees something no one can explain. That brightness? It doesn't fade with distance the way comets do. Instead, it holds flat, stubborn, artificial looking. If the light is natural reflection, the body must be enormous. If it's small, something is amplifying the light. Either way, the math cracks. And just when everyone thinks the mystery's solved, Hubble trims the size estimate down to 5 kilometers, a normal comet. Relief, right? Wrong. Because the smaller it gets, the stranger it behaves. Its orbit threads through the system like a guided tour past Jupiter, skimming Mars at 0.19 AU, heading toward Venus. That's not chaos, that's choreography. Random debris doesn't follow flight paths that clean. Loeb calls it the tidy trajectory problem. The rest of the field calls it coincidence. But the coincidences stack. It's bright when it should be dark, silent when it should hiss, aligned when it should wander. And here's the kicker, there's no detectable non-gravitational acceleration. Every comet vents gas, tiny jets that nudge the orbit. Atlas? Nothing. No push, no drift, no measurable recoil. That means one of two things. It's unbelievably massive, or it's venting with perfect symmetry. Neither makes sense. By late October, the story takes another turn. The object's about to slide behind the sun, gone for weeks, unreachable. Astronomers call it conjunction. Loeb calls it an opportunity. If anything wanted to change course, unseen, he writes, this is the window. NASA's official tone stays calm. Predictable orbit, no anomalies. But under that calm, every data team is running double checks, because if the path shifts even a fraction when it reappears, physics itself takes the hit. So the question becomes sharper. Is 3I Atlas obeying gravity or using it? And just when the debate hits its peak, the light starts flickering. That's where the real argument begins. You think math never lies. Sometimes it just tells the story too early. From the moment 3I Atlas appeared, the equations started fighting each other. Every parameter, mass, composition, motion, fit one model while breaking another. It was as if the universe had built a contradiction and dared us to notice. Now here's where it gets impossible. Normal comets heat up as they approach the sun, venting gas that pushes them slightly off course. We call that non-gravitational acceleration. To 3I Atlas, 0. The orbit is perfect, untouched, as if nothing is leaking at all. But telescopes see a coma, a faint halo of gas and dust. How can a comet breathe without moving? Loeb's team runs simulations. To stay that stable, it would have to weigh tens of billions of tons, so dense the gas jets barely matter. But if it's that heavy, it shouldn't have survived interstellar ejection in the first place. Paradox number 1. Then there's the chemistry. Early spectra show a reddish hue. No clear gas signatures, no carbon dioxide, no methane. Just reflected sunlight off dusty organics. Then, weeks later, NASA's SPHERE-X telescope picks up CO2, after all, far too much of it. An 8-to-1 ratio of carbon dioxide to water. That's not odd. That's unheard of. The only time we've ever seen that ratio is in laboratory models of terraforming experiments. The data is real, but the context doesn't exist. And it keeps going. The brightness curve flares too soon, billions of kilometers from the sun, where ice shouldn't even vaporize. The coma expands smoothly, not explosively, like a controlled release. The trajectory never wobbles. The tail doesn't twist. Every chaos we expect is missing. Now, you could explain each piece individually, mass, chemistry, alignment, but not together. Stack them, and the pattern looks like behavior. Not human, not alien, just intention hiding in physics. But here's the part that changes everything. In late September, a solar storm hits it head-on. A coronal mass ejection strong enough to tear tails off normal comets. Encke lost its entire plume to one like this in 2007. 3I Atlas doesn't even flinch. Its magnetic field flexes, stabilizes, reforms. Not even a dent in brightness. And that's when even the skeptics stop laughing. Because objects that shouldn't survive keep surviving. Comets that shouldn't glow keep glowing. Equations that should close keep opening. So now the story splits in two. The official version, a robust interstellar comet behaving unusually. The unofficial whisper, maybe robustness was the point. Maybe some worlds build things to last longer than stars. The numbers stay clean. The mystery stays open. And the next event, October 29, the day it slips behind the sun, will decide which side of the ledger this story ends up on. Because if it comes back the same, it's just physics. If it comes back different, just slightly different, then it isn't just passing through. It's responding. You think orbits are chaos. They're not when someone's steering. Look at the pattern again. Not the dots, not the headlines. The geometry. 3. I Atlas isn't cutting through the solar system, it's tracing it. 5 degrees. That's how close it sits to the ecliptic plane, our planetary highway. You could drop it on a NASA trajectory map, and it would blend in with our own probes. Jupiter, then Mars, then Venus, skipping the Earth like it knows to stay out of sight. Random debris doesn't fly that clean. That's choreography. Astronomers call it coincidence. A once-in-10,000 alignment. But you don't string coincidences together like beads on a perfect curve. You don't pass 3 major planets in sequence unless something or someone calculated it. The gravitational assists line up too well. Each close pass could lend velocity, save energy, and adjust course using the same math human engineers used to sling Voyager toward the stars. You think nature rehearses gravity assists? It doesn't. We do, and the dates make the pattern worse. July 1 discovery. October 3. Mars flyby at 0.19 AU, just 28 million kilometers. Then October 29, perihelion. The moment it ducks behind the sun, vanishing from every telescope on Earth. That's not bad luck for astronomers, that's perfect timing for an operation. Because behind the sun, the solar system goes blind. No radar, no optical tracking, nothing. If you were going to pivot, burn, or split into smaller bodies, that's when you'd do it. NASA won't say that, of course. They'll tell you the orbit's stable, the math predictable, the physics ordinary. And maybe it is. But then ask yourself why it keeps choosing the one path that hides the truth every time we look. Loeb calls it the tidy trajectory problem. Others call it paranoia. The numbers just call it suspicious. Now picture this. A craft the size of a mountain, built from ice and dust, sliding between planets on an interstellar reconnaissance run. Every pass collecting magnetic data, atmosphere readings, radiation density scanning us the same way we've scanned Mars for decades. If that sounds crazy, ask why it keeps acting like a surveyor and not a comet. Because comets don't care about precision. They care about survival. 3. Atlas seems to care about timing. And there's another thing. The approach velocity isn't what you'd expect from an object flung at random by stellar gravity. It's tuned, slower than it should be, like it was deliberately decelerated before entering the inner system, enough to make a close pass near Mars possible without slingshotting out of sight forever. Deceleration in interstellar space? That's not physics. That's propulsion. Still, NASA holds the line. We see a comet doing comet things. Sure. But comets don't aim for conjunction windows. Comets don't trace ecliptic corridors. Comets don't survive solar storms without tail disruption. Yet 3I Atlas did. On September 24 to 25, a coronal mass ejection slammed into it, something that shredded Comet Encke in 2007, and 3I Atlas didn't even flinch. Its coma held. Its tail didn't shear. Nothing. The universe blinked, and it didn't. That's not luck. That's design. So what happens next? On October 3, while you're asleep, 3I Atlas passes Mars. Every probe on and around that planet. Perseverance, Curiosity, MRO, will be watching. And if anything changes in its brightness, its vector, its chemistry, even by a fraction, the headlines you're reading today will look like denial tomorrow. Because once that data comes in, we'll know whether 3I Atlas is following gravity or writing its own script. And here's the part that keeps every astronomer up at night. If it is writing a script, we're in it. Because after the Mars flyby, it disappears behind the sun and comes back on a new stage. And if that new orbit curves closer to Earth just a few degrees tighter, then we're no longer the audience. We're the next act. So watch the dates. Watch the silence after October 3, because when an object this precise goes dark behind the sun, one of two things will happen. Either it reappears exactly where the math says it should, or the math stops working. And if the math stops working, it means something out there just decided to break our rules. And that's where we're going next, into the moment Mars blinks first and the universe answers back. You think science doesn't dare ask crazy questions? You're wrong. Because sometimes the math corners you until the only way out sounds like science fiction. And that's exactly where 3I Atlas has pushed us. So let's ask it outright. Is 3I Atlas alien technology? Not the clickbait version, the data version. The version that keeps astrophysicists awake at 3 a.m., staring at numbers that don't make sense. Harvard's Avi Loeb calls it a thought experiment, but you can hear it in his tone. He knows the odds are lying. He built a ranking system for anomalies, the Loeb scale. 0 means a boring space rock. 10 means undeniable technology. And 3I Atlas? He won't give it a number, but the subtext sits somewhere around a 6, the zone where physics starts sweating. Start with the mass, 33 billion tons. That's the conservative estimate derived from its lack of non-gravitational acceleration. Every comet vents gas, gets nudged, wobbles a little. Atlas doesn't. It moves like a perfect dead weight. To resist that much thrust, it must be enormous or engineered. Because a hollow structure with internal support could weigh the same, move the same, and fool every algorithm we've got. A mountain of ice behaves one way, a shell disguised as one behaves another. Then there's the composition. The 8:1 carbon dioxide to water ratio recorded by NASA's SPHEREX telescope is nearly unheard of. 8 times more CO2 than H2O, a chemistry flipped on its head. Loeb wonders if it's a shield, a thermal coating that keeps the interior stable while drifting between stars. Carbon dioxide ice reflects heat differently. It could act like insulation. If that's true, it isn't just surviving the void, it's built for it. And that green glow everyone keeps talking about? It wasn't supposed to happen. The spectra taken in August 2025 showed almost no diatomic carbon. A month later, September 7, the comet turned vivid emerald. Like a system waking up. One day inert, the next alive. NASA says, chemical transition. Loeb says, activation threshold. If you're building an interstellar probe, you'd give it a trigger. Heat, radiation, proximity to a star. Atlas crossed that line and flared like it was switching on. Still think it's all coincidence? Stack the odds. Discovery July 1 alignment within 5 degrees Mars flyby October 3 hidden perihelion October 29. Each event improbable on its own. Together they form a pattern too perfect for comfort. Coincidence doesn't schedule itself. Now imagine what happens if Loeb is even half right. An object that big, that stable, that deliberately timed, moving through our inner system isn't a tourist. It's reconnaissance. Maybe passive, maybe active, maybe cataloging every planet it passes. We've done the same thing. Pioneer, Voyager, New Horizons, all coded with data plaques and transmitters, all drifting now through someone else's backyard. What if 3I Atlas is their version of us? But let's stay grounded. Loeb's point isn't to scream aliens. It's to demand discipline. He says if an interstellar object crosses the Loeb scale 5 threshold, humanity should treat it as a global science emergency, a coordinated response. Not panic, not denial, observation, because these things move fast. Once they're gone forever. This isn't SETI waiting decades for a radio ping. This is a 6-month window before the evidence leaves the solar system. Right now, every space agency is watching. The Mars Reconnaissance Orbiter will image it on October 3. ESA's JUICE and NASA's Juno might catch glimpses near Jupiter in November. Ground scopes across Chile, Hawaii, and the Canary Islands are feeding petabytes of telemetry into models that still can't agree on a single parameter. Every update deepens the mystery. And here's where the question turns sharp. If 3I Atlas isn't natural, what does that mean for us? Loeb mentions the dark forest hypothesis, the idea that civilizations stay silent because broadcasting your presence is suicide. In that kind of universe, you don't send greetings, you send scouts, quiet ones, probes that look like comets, objects that gather intel and never speak. If that's what we're dealing with, 3I Atlas wouldn't announce itself. It would listen. Now, none of this breaks NASA's position. Officially, it's still a comet. The data still fits, mostly. But mostly is doing a lot of work. The mass doesn't fit. The chemistry doesn't fit. The orbit doesn't fit. When the same object breaks 3 categories at once, you stop calling it coincidence. You start calling it intent. So where does that leave us? Somewhere between awe and ignorance. Maybe this is how first contact actually looks, not flashing lights, not radio messages, just a rock that shouldn't exist quietly rewriting our equations. Or maybe it's nothing more than nature showing off. But either way, October 29 is the line in the sand. When 3I Atlas disappears behind the sun, we lose our only chance to know for sure. Because if it re-emerges in late November on the same trajectory, fine, we exhale. Physics wins again, but if it comes out even a few thousand kilometers off course, if the numbers drift by a fraction, that's not gravity. That's a maneuver. And then every telescope on Earth will be pointing at the same spot for the same reason. To see if something out there just decided to stay. And if it does, if 3I Atlas locks into orbit instead of leaving forever, the question changes from what is it to what does it want? Because the moment a visitor stops passing through and starts circling, it's no longer a comet, it's a neighbor. And the next chapter is what happens when Mars blinks first. You think the sky is honest. It's not. Space hides things for a living. And this time, it's about to hide something we might never get back. The 29th of October 2025. That's the date circled on every astronomer's calendar. The moment when 3I Atlas slips behind the sun, into the one blind spot every telescope on Earth fears. A total blackout. For weeks, we won't see a single pixel of it. And that's exactly what makes this window terrifying. When an interstellar object vanishes, it's not like watching a plane fly behind a cloud. It's leaving every instrument blind, optical, infrared, radar. The sun's glare saturates detectors, burns out sensors, drowns the background noise so completely that even billion-dollar telescopes like Hubble and JWST have to look away. During conjunction, the solar system goes deaf. If you wanted to make a move, this is when you do it. And that's what Avi Loeb keeps pointing out. He calls it the maneuver window. In orbital mechanics, timing is everything. You fire engines where gravity does the most work for you. The perihelion, the point closest to the sun, is that moment. A spacecraft can burn a tiny amount of fuel there and get a massive change in velocity, thanks to the Oberth effect. It's rocket physics, 101. But you can also use that same trick in reverse. Slow down instead of speed up. Bleed off energy instead of gaining it, and let the sun's gravity pull you into a permanent orbit. If 3I Atlas were to do that, even slightly, it could trap itself inside our solar system forever. NASA knows the math. So does the European Space Agency. Both agencies are tracking its ephemerids, the predicted coordinates of where it should reappear once it clears the sun's glare in late November. But there's a problem. Our margin of error grows every day, it's invisible. Even a tiny thrust, something as small as a sustained 0.1 mm per second change, could shift its reappearance by tens of thousands of kilometers. And we wouldn't know until it's too late to react. It's like playing chess with a blindfold on. You make your move, you hear a sound across the board, and you have no idea what piece just shifted. For weeks, that's what astronomy becomes: waiting, guessing, recalculating. And if 3I Atlas isn't playing by our rules, it could reappear somewhere no one expects. Now, the official stance. There's no reason to think it will deviate. NASA says its orbit is stable, the math is solid, gravity is enough. But here's the hook: so was Oumuamua's. Until it wasn't. That first interstellar visitor in 2017 showed an unexplained acceleration after perihelion. A gentle push with no clear cause. No outgassing, no jetting. Just motion that defied every force they could measure. And 3I Atlas? It's already heavier, brighter, stranger. If it performs even a fraction of that behavior, we're looking at something the equations can't swallow. Loeb calls it the repeat test. If it happens twice, it's not a fluke. It's a pattern. And then there's the green glow. It appeared weeks before conjunction, then stabilized. Most comets flare and fade unpredictably. But 3I Atlas's light curve doesn't just fluctuate, it oscillates, like a signal. Regular, controlled, rhythmic. Astronomers will tell you it's the chemistry molecules fluorescing under ultraviolet light. But the synchronization is unnerving. It's like watching a heartbeat on a monitor that refuses to die down. Behind the sun, that glow will vanish. No monitoring, no confirmation, just silence. Some call it poetic, others call it cover. Because if you were trying to mask a course correction, hiding behind the single brightest object in the solar system is exactly how you'd do it. But even silence speaks. We'll still know something happened if, when it returns, the orbit has shifted even by a hair. And that's why every observatory from Cerro Paranal to Mauna Kea is preparing for the reappearance window in late November. Thousands of eyes, hundreds of instruments, all waiting for the first blink of that faint green light just above the dawn horizon. And here's the detail no one wants to talk about: the trajectory re-entry angle. If 3I Atlas executes even a minor reverse burn maneuver during conjunction, it could transform from a hyperbolic escape path to an elliptical orbit bound to the Sun, looping through the inner solar system again. Which means it would come back, not in 1,000 years, in a few months. That's not a visit. That's a return schedule. Now, imagine it doesn't just loop back harmlessly. Imagine it drifts closer with each orbit, using planetary gravity, assists Jupiter, then Mars, then Earth. You wouldn't even call that an approach. You'd call it a survey pattern. Loeb doesn't say it outright, but you can hear the weight in his words. If 3I Atlas stays, it changes everything. He's right, because permanence means purpose. Passing objects don't choose to stay. Machines do. And if it does stay, the next question isn't scientific. It's existential. What do you do when something from another star decides to share your orbit? How do you study something that might be studying you back? No one has an answer. Not NASA, not ESA, not even Harvard. They'll tell you we have protocols for near-Earth asteroids, deflection drills, planetary defense systems. But those plans assume rocks, not reconnaissance. And no amount of math prepares you for intent. So we wait. We watch. We pray the numbers behave. But deep down, everyone knows what this blackout means. Once 3I Atlas disappears, anything is possible. We could wake up to a stable orbit or a completely new one that wasn't decided by chance, but by choice. And if that happens, if the data shows a deviation when the light returns over the horizon, every telescope on Earth will turn toward that emerald flicker in the dawn and ask the same question: what did it do while we weren't looking? Because the truth about 3I Atlas isn't just in what we see, it's in what it does when we can't. You think color is just color. It's not. In astronomy, color is chemistry, and chemistry is truth. And 3I Atlas just changed its colors in a way that no one fully understands. Early August, dull, reddish reflection, typical for a cold comet far from the Sunday. But by September 7, it wasn't dull anymore. It was glowing green, unmistakably, unnervingly green. Now, green comets aren't rare. They happen when sunlight excites diatomic carbon molecules, making them fluoresce. But the data didn't match. Earlier spectra from Kitt Peak Observatory showed almost no diatomic carbon at all. It should have stayed dark. Instead, something flipped, almost overnight. Scientists confirmed the color, but the mechanism? Still being studied. Some suspect deeper layers of ice were exposed. Others think solar storms cracked the crust, releasing trapped carbon compounds. And then came the twist: a solar CME hit it around September 24-25. The same week the glow intensified. That green light became a global phenomenon. Photos from Namibia, Chile, Hawaii. Every image the same hue, the same strange pulse. NASA's Hubble and Webb telescopes recorded elevated CO2 levels right as the color shifted. Coincidence? Maybe. Or maybe it was what physicists call an activation threshold, the exact point when sunlight becomes strong enough to change an object's behavior. No one is claiming alien technology. These are natural mechanisms that can occur under extreme heat and radiation. But the timing, the suddenness, the precision, it all feels orchestrated by the universe itself. Like watching a sleeping giant blink awake for the first time. And here's the question that hangs over every observatory. If color reveals chemistry, and chemistry reveals history, then what history just lit up inside 3I Atlas? Because when something turns green in the cold vacuum of space, it means energy is flowing, systems are changing, and reactions are happening where silence should rule. Something inside 3I Atlas has stirred, and whatever woke it up may be the same force that will decide what it becomes next. You think the sun is distant. It's not. Its reach stretches across billions of kilometers. And last month, It decided to remind every comet, planet, and satellite who really runs this system. September 24, 2025. That's when a coronal mass ejection, a CME, ripped off the Sun's surface and blasted through space straight toward 3I Atlas. These eruptions are monsters. Clouds of plasma traveling at 1,000 kilometers per second, each packed with billions of tons of charged particles. When they hit a comet, they don't just brush it aside, they tear it open. Back in 2007, a similar event hit Comet Encke and literally ripped off its tail. Its magnetic field collapsed, its plasma tail snapped clean like a rope under tension. That's what solar storms do. They erase fragile objects. They strip the weak bare, but 3I Atlas, it didn't flinch. Not a flicker. The solar wind slammed into it, and every instrument pointed at the scene. SOHO, stereo, solar orbiter recorded the same thing. No break in the coma, no tail disconnection, no collapse in brightness. Nothing. The storm howled, and 3I Atlas just kept moving, silent, steady, green. That's not defiance. That's endurance. And endurance demands explanation. NASA's analysis points to mass shear inertia. A body weighing tens of billions of tons simply shrugs off what would annihilate smaller comets. A heavy nucleus means high gravity, tightly bound material, less affected by solar pressure. Logical, predictable. But even within those explanations, there's an edge that doesn't fit, because comets, no matter how massive, react. Their plasma tails distort, their magnetospheres flicker. They leave traces, kinks, flares, asymmetries. Atlas left nothing. It was like the storm passed through a void. Like there was no magnetic field to disrupt, no charge to scatter. Scientists noticed that. Quietly, carefully. No wild theories, no controversy, just quiet surprise. It's unusually stable, one ESA observer noted. Unusually stable. The kind of phrase scientists use when they've run out of adjectives that sound objective. That storm should have been chaos. Instead, it became a test, and Atlas passed. Its coma stayed symmetrical, its luminosity unchanged, its motion perfectly consistent with gravity. No measurable non-gravitational acceleration, no jitter, no deviation. That kind of stability is impressive. It's the mark of something built solidly by nature, or more abstractly, something with design-like resilience. But official reports emphasize what they should. It's still a comet. It behaves like one, looks like one, and fits the models just at the extreme edge of what's possible. Still, you can't ignore the poetry and the timing. A week after the green glow appeared, the sun unleashed a storm that would have destroyed any weaker traveler. Instead, 3I Atlas glowed brighter, as if the hit charged it rather than hurt it. Could the CME have energized chemical reactions in its coma, amplifying the fluorescent green? Possibly. Solar radiation can catalyze carbon compounds, excite diatomic carbon, intensify emission bands. There's a paper in the works right now, modeling exactly that scenario. It might explain everything, or it might open another mystery. And then comes the eerie silence. Every CME event produces a radio burst, static echoes through space. The electromagnetic signature of the collision. For 3I Atlas, there was almost nothing. The usual spectrum noise was faint, muted, as if the plasma found no surface to spark against. That's strange. Again, not unnatural, just unexpected. The simplest explanation? The coma's density was lower than assumed, absorbing less radiation. But if that's true, it means the visible glow we're seeing isn't coming from a dense gas cloud at all. It's coming from the surface itself. Whatever that surface is made of, it takes punishment better than any ice we know. The temperatures near perihelion will soar beyond 200 degrees Celsius on the sunward side, cold enough to freeze iron on the dark side, hot enough to vaporize organics. On the bright side, a thermal swing that would shred ordinary rock. Yet 3I Atlas stays smooth, consistent, symmetrical. It's like it was built for this exact gauntlet. NASA and ESA remain cautious, focused on data. Exceptional stability under high-energy solar impact, reads the latest joint summary. Not alien, not engineered, just exceptional. Because that's what good science does. It resists panic and keeps counting photons. And yet, behind those measurements, there's a quiet thrill. We've never seen an interstellar object survive a solar storm up close before. This is brand new data, the kind you wait lifetimes for. Now the countdown moves on. Perihelion is next. October 29. That's when 3I Atlas will reach its closest approach to the Sun and vanish behind its glare. And if the CME was the rehearsal, perihelion is the performance. Because that's where gravity, heat, and radiation all peak, where anything pretending to be a comet gets exposed. The solar system is about to find out whether 3I Atlas burns, breaks, or endures again. And if it endures twice? If it passes through the Sun's furnace untouched just as it shrugged off the storm, then we'll have to admit something simple and awe-inspiring. This interstellar traveler isn't just rare, it's resilient beyond reason. Whatever 3I Atlas truly is, nature made it stronger than we imagined. And the closer it gets to the Sun, the more it feels like the universe is daring us to find out why. You think the mystery is about distance. It's not. It's about scale, and how the numbers keep changing every time we look closer. At first, scientists said 3I Atlas was a giant, 20 kilometers across, glowing like a city in space. But when Hubble locked on in late August, the picture changed. The brightness wasn't from a massive solid body, it was from dust. The nucleus itself, somewhere between 0.6 and 5.6 kilometers wide, a tenth of what we thought. Overnight, the monster became manageable. The giant became a ghost, but this is where things get complicated. Because that size correction didn't fix the bigger question, it made it worse. If the object was smaller than expected, then why was it still so bright when it was discovered? At a distance of over 4 billion kilometers, sunlight should have been too weak to light it up like that. Most comets that far out are invisible, silent, frozen stones drifting through the void. But Atlas glowed early, and it glowed strong. Something was reflecting more light than it should. NASA's explanation is careful, data-driven. A dense coma, they say. A thick cloud of dust amplifying reflectivity. Logical. But that answer carries a quiet contradiction. A dense coma means intense outgassing, which should also mean detectable thrust, a measurable push on its orbit. Yet no non-gravitational acceleration has been recorded. The numbers stay too clean. No wobble. No jetting. It's moving like a perfect sphere, in a vacuum, unbothered by its own activity. That's rare. Not wrong, just rare enough to make people look twice. And the weight. 33 billion tons. That's the minimum required to keep that trajectory stable given its outgassing rate. 33 billion tons of ice, rock, and dust, more than 1,000 times heavier than Oumuamua or Borisov. That mass doesn't just bend gravity, it commands it. If you picture a mountain drifting through space, you're still undershooting. This thing is more like a small moon, crossing our planetary lanes at 210,000 kilometers per hour. Now think about what that means. The bigger it is, the more mass it needs. The more mass it has, the more energy it should take to escape its home system. And the harder it should be to accelerate across interstellar distances. The physics says massive bodies don't get ejected easily, which means if 3I Atlas truly weighs that much, it didn't leave its original star system by accident. Something, gravity, collision, maybe even intention, gave it one violent push. Then comes the paradox. If the coma is boosting brightness, the mass shouldn't be that high. If the mass is that high, the coma shouldn't be that bright. It's a feedback loop of contradictions, like the object refuses to fit in any single box. Some call it calibration error, others call it design. Avi Loeb calls it a problem worth losing sleep over. Still, no one disputes the data. Hubble's imaging confirms the smaller nucleus. Webb's spectroscopy confirms the heavy composition. And every new reading adds another layer to the puzzle. Atlas is now officially large but not monstrous, stable but not quiet, predictable but not normal. It's the same story over and over. We understand each part separately, but together they break the model. So what if it's not the size that matters? What if it's the density? If you keep the same mass but shrink the volume? The math says 3I Atlas could be made of something far denser than rock or ice. Maybe metallic compounds, maybe an unusually compact carbon lattice. Not alien, just exotic. Materials forged in conditions we don't see anymore. Born around another star, billions of years ago. The kind of matter that turns into a mirror when sunlight hits it. That would explain the brightness. That would explain the silence after the CME. It would explain a lot, but not everything, because density doesn't explain the shape. Hubble's light curve shows almost no variation. That means Atlas isn't tumbling the way most comets do. It's rotating slowly, almost deliberately, presenting the same face to the sun for long periods. That's weird. Natural bodies spin. This one coasts. Either it's balanced like a gyroscope, or something inside is keeping it stable. NASA notes that the rotation rate remains undetermined due to limited light curve variation. Translation: it's too smooth to measure. So yes, 3I Atlas might not be 20 kilometers wide, but what's left is arguably stranger. A small, stable, mirror-bright body that behaves like it's immune to chaos. The deeper we measure, the more unnatural the normality becomes. And that brings us back to the one word no one wants to say too loudly: intentionality. Because maybe this is the point. Maybe the confusion isn't a bug, it's the message. You make something big enough to be noticed, small enough to be ignored, heavy enough to stay stable, light enough to maneuver unseen. You send it where gravity hides your moves. You cover it in ice so it looks ancient, and then you let scientists argue while you pass through unnoticed. Of course, there's no evidence of that. There's only physics, and physics doesn't lie. But sometimes, it whispers. And right now, it's whispering through every telescope we own that 3I Atlas is the exception we can't stop chasing. So when you look at that green point on the orbital map, remember this: its size may have collapsed, but its mystery has only expanded. Because what we thought was a frozen relic now feels more like a calculated presence, a perfect equation wrapped in dust, and the closer it drifts toward the sun, the more it feels like it's getting ready to show us what all that silence was hiding. You think the mystery means chaos. It doesn't. Sometimes the strangest stories end up being the simplest ones. And in this case, every major agency, NASA, ESA, and the Minor Planet Center agrees. 3I Atlas is a comet. No cover-ups, no conspiracies. Just data, consistency, and physics doing exactly what it's supposed to do. The official story begins the way science always does, with evidence. As 3I Atlas got closer to the sun, instruments from the James Webb Space Telescope, Hubble, and SPHEREx all caught the same pattern. A coma, a tail, a gradual brightening curve that matched solar heating. Spectroscopy revealed clear carbon dioxide emission lines, the unmistakable fingerprint of cometary outgassing. This wasn't some inert rock or alien probe drifting by. It was breathing gas, shedding dust, behaving exactly the way a comet should. The data tells a steady story. On the 6th of August 2025, Webb measured the comet releasing roughly 150 kilograms of gas per second, mostly CO2 and water vapor. By late September, that rate had tripled. Its coma stretched thousands of kilometers across, forming a visible halo even in mid-range telescopes. That's textbook behavior. Every outburst, every flare, matched predictions from standard sublimation models. NASA's Tom Statler, lead scientist for small bodies, put it bluntly: it looks like a comet. It does comet things. And he's right. The orbit fits too. It's hyperbolic, yes, meaning it's not bound to the sun, but that's exactly what an interstellar comet's orbit should look like. It came in from deep space, passed near the sun, and will leave again, never to return. The inclination angle of roughly 5 degrees is low, but not impossible. Random chance favors shallower entries occasionally. The velocity, about 210,000 kilometers per hour, fits the escape speeds expected for debris kicked from other star systems. Every piece lines up. Even the green glow that captivated headlines has a natural cause. Spectral analysis confirms diatomic carbon as the source, the same molecule that makes comets like C divided by 20, 22E3, ZTF, glow green before fading. The sudden color change? Perfectly normal when sunlight reaches critical heating thresholds and begins exposing fresh ice beneath the surface. The timing may look uncanny, but it's chemistry, not conspiracy. Then there's the mass problem, that 33 billion ton figure that caught everyone's attention. It sounds impossible until you remember. Interstellar space doesn't follow our sample size. We've only discovered 3 interstellar visitors so far, Oumuamua, 2I divided by Borisov, and now 3I Atlas. 3 objects don't make a pattern. Statistically, it's meaningless. The fact that this one happens to be larger just means we got lucky, or unlucky, depending on your perspective. But randomness doesn't always look random when you zoom in. Sometimes, chaos creates patterns that look deliberate. Astronomers emphasize that this is what science is supposed to look like. You find anomalies, you question them, and then you test them until they collapse into sense. Loeb's alien probe hypothesis isn't being censored, it's being measured, and so far, the measurements favor nature. That's the beauty of open data. NASA publishes every update in real time. The Hubble image from the 21st of July 2025 shows a teardrop-shaped dust coma, faint but visible, and the background stars streaked from tracking motion, exactly what you'd expect if the comet were moving at interstellar speeds. The apparent forward glow, explained by motion blur. No hidden engines, no headlights, just exposure physics. The European Space Agency backed that up with its own imagery. The Solar Orbiter and Stereo spacecraft confirmed no anomalous thermal signatures, no excess infrared radiation, no radio emissions, nothing that looks artificial. When the solar storm hit on September 24, 25, the comet's tail flexed exactly as it should, then stabilized. The system works, the science holds, and the trajectory? Perfectly accounted for. Every gravitational tug from Jupiter, Mars, and Venus is baked into the model. The alignment looks neat, but it's a coincidence that occurs more often than you'd think. The solar system's plane is a big target. Interstellar debris flying in random directions has plenty of chances to line up just right. Astronomers call it observational bias. We're more likely to spot the ones that pass near our planetary plane because that's where our telescopes are already pointed. If anything, 3I Atlas is a scientific gift. A time capsule from another solar system, carrying clues about chemistry and planetary formation in places we'll never reach. It's CO2. Heavy composition tells us that comets beyond our sun might have very different temperature histories. Colder origins, slower rotations, older ices. The 8:1 CO2 to H2O ratio might seem bizarre, but it's not unnatural. It just means 3I Atlas formed farther from its parent star, in conditions where water couldn't freeze easily but carbon dioxide could. Studying it expands our catalogue of how diverse planetary systems can be. And as for danger, there is none. Trajectory analysis shows that at its closest, 3I Atlas will stay more than 1.8 astronomical units from Earth, about 270 million kilometers, nearly twice the distance between the Sun and our planet. Even when it passes Mars at 0.19 AU, 28 million kilometers, it poses zero threat. ESA's impact probability models read 0 to 4 decimal places. That's as safe as space gets. So yes, there's still mystery, but not the kind that breaks the laws of physics. The kind that makes them more interesting. A comet that traveled across the galaxy to tell us how alien star systems build their worlds. An object that challenges our assumptions without defying them. That's what makes this discovery extraordinary. Not because it's impossible, but because it's real. Even Avi Loeb admits that the simplest answer might win. If it's a comet, It's a remarkable one, he says. And he's right. That doesn't kill the wonder. It deepens it, because the universe doesn't need technology to amaze us. Sometimes, it just needs a frozen wanderer glowing green in the night sky, a traveler from another sun passing through ours, whispering secrets in the language of light. And maybe that's the truth buried in all this noise. We don't need aliens to make the universe extraordinary. It already is. But what if the universe still hasn't shown us everything? What if nature itself is trying to tell us something deeper, stranger, something we're just beginning to decode? You think mystery kills science? It doesn't. It fuels it. Every discovery starts as an anomaly, a number that doesn't fit, a signal that won't behave, a question that refuses to die. And 3i Atlas is still that question. Even after every statement, every press briefing, every official reassurance that it's just a comet, the numbers keep whispering. Look closer. Skepticism doesn't mean denial. It means testing the margins, pulling on the threads that don't quite weave into the pattern. And for 3i Atlas, those threads are still dangling. The brightness, the trajectory, the mass, the timing. The skeptic's ledger isn't a conspiracy list, it's an inventory of odds that refuse to stay quiet. Start with the light curve, the way its brightness changes over time. The models said it should flare gradually as it neared the sun, following predictable thermal physics. But it didn't. It brightened early, far beyond Jupiter's orbit, then plateaued. That's not impossible, but it's strange. Most comets sleep until they're warm. Atlas woke up early, like it was expecting the heat. Some astronomers think solar radiation triggered subsurface CO2 vents earlier than normal, forcing a premature coma. Others suspect the early glow was reflective. Maybe the surface composition is unusually shiny, coated with crystalline carbon or frozen gas that reflects sunlight better than expected. Either way, it's odd enough to stay in the ledger. Then there's the trajectory problem. The ecliptic alignment within 5 degrees is still a statistical outlier. The odds, roughly 1 inch 500 for such precision, don't prove intent, but they invite curiosity. Add in the planetary flybys, Jupiter, Mars, Venus, each within a window that Loeb calculated at 1 inch 20,000 probability, and suddenly the ledger fills with improbable entries. You can explain each one individually. Together, they sound rehearsed. But let's stay grounded. The skeptic's job isn't to shout alien. It's to ask why. Why this orbit, this timing, this pattern? Why is October 29 the moment of solar conjunction exactly when Earth can't see it? And why does every variable seem to land right on the edge of coincidental but remarkable? There's no rule against coincidence stacking, but even coincidence has limits. Then there's the non-gravitational acceleration, or rather, the absence of it. The comet vents gas, releases dust, yet its orbit remains pristine, purely gravitational. That's rare. It implies either incredible mass or perfectly symmetrical outgassing. Nature isn't known for perfection. Most comets wobble. Atlas glides. That smoothness goes into the ledger too. The mass estimate itself, roughly 33 billion tons, is another quiet rebel. It fits the observed data, but it bends the statistical curve of interstellar debris. Finding an object that heavy this early in our surveys, the third ever found, is like rolling 3 dice and getting all 6s twice in a row. Possible? Yes. Expected? No. Loeb compares it to winning the cosmic lottery twice before buying your 3rd ticket. Then comes the green glow, another entry that refuses to die down. The diatomic carbon explanation works, but the timing still doesn't. Atlas's spectra showed almost no C2 bands before August, then suddenly lit up in September right as the solar storm struck. Cause and effect? Maybe. Or maybe the storm triggered chemical transitions beneath the surface that no model predicted. Either way, that one goes in the ledger too, not as proof of anything unnatural, but as a reminder that nature loves drama. Now, skeptics aren't enemies of science. They're its immune system. For every headline shouting, alien ship, there's a paper saying, here's the math. For every blog post that says, intent, there's a data set that says, physics. But that balance is what keeps truth alive. 3I Atlas isn't dividing scientists, it's reminding them how to think. Even NASA quietly welcomes it. Every anomaly means more data, and every data point helps us refine the model for the next interstellar visitor. The Vera Rubin Observatory, set to go online soon, will find many more, maybe hundreds, and when it does, we'll finally see whether 3I Atlas was the rule or the exception. If we find more like it, this one becomes normal. If we don't, it becomes legend. And that's the subtle brilliance of science. It never settles for comfort. The skeptic's ledger doesn't accuse, it observes. Each improbable feature becomes a new line of inquiry, not a conclusion. Because the truth isn't found in declarations, it's found in persistence. So, here's what we know. 3I Atlas is behaving mostly like a comet. Its tail forms, its coma brightens, its spectrum shows carbon dioxide. It's following a hyperbolic orbit that fits gravitational laws perfectly. Every model matches, except where it doesn't, and those gaps, those tiny cracks in the story, are where discovery lives. Think of it this way. Every time we've called something impossible, it's been an invitation for progress. Radio waves, black holes, dark energy. Once upon a time, those were ledger entries too, unsolved, uncomfortable, unbelievable, until we solved them. 3I Atlas might be the same. The universe testing whether we're still paying attention. So maybe it's not alien. Maybe it's something even rarer, a natural phenomenon we've never encountered before. A fragment of another sun's creation, older than our species, shaped by forces we can barely model. That's not a letdown. That's history. Still, the ledger stays open. The comet hasn't finished its journey. It hasn't passed perihelion yet. And if something changes brightness, trajectory, chemistry, every line might need rewriting. Because the ledger isn't about proving anything. It's about keeping the door open until the evidence closes it. And when that evidence finally arrives, when 3I Atlas reappears from behind the sun, and we see what, if anything, changed, that's when we'll know whether this was just another visitor, or the universe hinting at something it's not ready to say out loud. You think everything out there is either alive or dead. It's not that simple. Between the living and the lifeless, there's a third category, the things that build life. And that's where a new theory has started to rise. It's called the planet seed hypothesis, and it's turning heads across every observatory that's been watching 3I Atlas. Two researchers, Dr. Suzanne Falsner of the Max Planck Institute and Dr. Michaela Bannister from the University of Canterbury, released a paper just days after the solar storm. Their claim wasn't about aliens. It wasn't about technology. It was about creation. They suggested that 3I Atlas could be something else entirely. A seed for planets. Not a machine, not a message, but the kind of building block that starts worlds. Here's how it works. When stars are born, they're surrounded by vast rotating disks of gas and dust, the raw material of planets. But forming something as big as Jupiter or Saturn takes time. Too much time. In many systems, the gas dissipates before planets can finish growing. Falsner and Bannister's idea is that solid interstellar seeds, massive rocky or icy cores like 3I Atlas, drift between star systems and act as shortcuts. When they plunge into these young disks, they provide a ready-made nucleus that gas and dust can cling to. The result? Instant planets. Cosmic jump-starts. And that changes everything. Because if they're right, objects like 3I Atlas aren't rare accidents, they're essential ingredients. The universe might be filled with these seeds, quietly fertilizing new solar systems as they wander the galaxy. They could be carrying the raw chemistry that kickstarts atmospheres, oceans, and maybe even life. Every world could trace its birth to one of these wanderers. That's what makes this theory so poetic and so powerful. It doesn't need aliens to be extraordinary. It just needs physics, chemistry, and time. Billions of years of silent travel, scattering the dust of creation wherever gravity allows. NASA calls 3I Atlas a scientific opportunity, a once-in-a-lifetime chance to study a fragment from another star system up close. Falsner calls it something bigger, a messenger of formation. If that's true, then 3I Atlas isn't here to threaten us. It's here to remind us where we came from. Because maybe the story of this comet isn't about invasion or mystery. Maybe it's about ancestry. Maybe what we're really seeing isn't alien technology at all, but the same cosmic seed that once fell into our own sun's cradle 4.5 billion years ago and gave birth to the world we now stand on. And if that's true, then 3I Atlas isn't just passing through space, it's passing through time, carrying the memory of creation itself. You think deep space is silent. It isn't. Sometimes it whispers, and 48 years ago, it screamed. The 15th of August 1977, a radio telescope in Ohio called the Big Ear recorded something it shouldn't have. A sharp, narrowband burst of energy lasting 72 seconds, too precise to be noise, too short to repeat. Astronomer Jerry Eman circled it on the printout and wrote one word beside the numbers. Wow. That's what history remembers it as, the wow signal. For almost half a century, no one's been able to explain it. No known satellite, no military transmission, no echo from Earth. Just a one-time signal from the direction of Sagittarius, 2.7 gigahertzes, a frequency window considered ideal for interstellar communication. Then silence. No repeats, no pattern, just a ghost in the static. Now, here's where it gets strange. When astronomers plotted the region of sky where that signal came from, it sat in an empty patch near the constellation Sagittarius. Nothing there. Nothing bright. Nothing active. Until the 1st of July 2025, when 3I Atlas entered the picture. And when its trajectory was mapped backward, it turned out to be passing through the exact same region where the wow signal originated. Coincidence? Maybe. Probably. But coincidences like this don't go unnoticed. Especially when Harvard's Avi Loeb quietly points out that of all the places in the galaxy an interstellar object could come from, that patch of sky, that exact radio coordinate, is one of the few with an unsolved mystery attached to it. Loeb's question wasn't, is this proof? It was simpler, sharper. What are the odds? The answer? Astronomically low. The wow signal region covers only a few degrees of the sky, a cosmic pinhole. The chance that an interstellar visitor from another star system would wander through that same space after half a century of silence is less than 1 in a million. It doesn't mean they're connected, but it means you can't dismiss it without at least blinking twice. So scientists did what they do best. They looked again. The SETI Institute reanalyzed the old data, while radio arrays in Australia and Puerto Rico scanned the path of 3I Atlas for new emissions. So far, nothing. No radio waves, no pulses, no digital signatures. Just the usual hiss of cosmic background radiation. The silence, if anything, got louder. But silence doesn't mean absence. It just means the message, if there is one, isn't written in radio. NASA, ESA, and independent observers have all confirmed the same thing. There's no evidence that 3I Atlas is transmitting anything. The official explanation for the wow signal remains unknown, but the most likely causes reflected signals from Earth, early communication satellites, or natural space noise are still on the table. NASA's position is clear. This is a comet, not a communicator. Still, the timing nags at the edges of imagination. The idea that an interstellar visitor could pass through the same coordinates as one of the greatest cosmic mysteries in modern history is enough to make even hardened astronomers pause. Because the truth is, 3I Atlas doesn't have to be the source of the wow signal to echo it. Its path alone has reignited the debate about whether we're really listening properly or whether something already spoke, and we just didn't understand. Consider this. What if the wow signal wasn't a message, but a test? A beacon sent once, 48 years ago, just to see who would notice. And now, decades later, something drifts by that same patch of sky, silent, unhurried, unbothered. Maybe that's coincidence. Maybe that's choreography. But whatever it is, it has our full attention. The wow coincidence, as it's now called, has become the perfect storm for speculation. You've got history, you've got mystery, You've got math that won't line up neatly. But you also have restraint. Because the experts, NASA scientists, SETI researchers, radio astronomers all agree on one thing. There's no solid link. And that's not a failure. It's the frontier. The same gap between curiosity and certainty that drives discovery forward. So where does that leave us? Right in the middle of the best story, science has to offer one that blurs the line between coincidence and design, between data and destiny. The wow. Signal might have been random noise. 3I Atlas might be a comet. But for the first time in decades, they're both in the same sentence again. And that sentence has the whole world looking up, because if the wow signal was the call, then maybe 3I Atlas is the reminder. Not proof, not contact, just a cosmic echo saying, you were right to listen. And now, as 3I Atlas races toward its closest approach to Mars, the question isn't whether we've heard from someone out there, it's whether something out there is about to see us. You think seeing is believing. It isn't. Not in the age of deep fakes, long exposures, and viral headlines. The moment 3I Atlas drifted into view, the internet exploded with claims, images, leaks. Everyone had a photo, and almost none of them were real. Let's rewind to the 5th of October 2025. NASA's Perseverance rover, parked in Jezero crater on Mars, turned its cameras toward the night sky. Astronomer and image processor Simeon Schmaus stacked 20-30-second exposures, combining them into a single frame. What emerged was a faint, diffuse glow, the first genuine photograph of 3I Atlas from another world. Not dramatic, not cinematic, just a smudge of greenish light barely brighter than the stars, exactly what scientists expected to see. But when Schmaus posted the image, social media did what social media does. Within hours, versions appeared with filters, color boosts, and contrast pushed to absurd levels. A faint comet became a glowing cylinder. Then came the headlines. Perseverance captures alien ship over Mars. A blurred moonbeam was suddenly the proof people had been waiting for. It spread like wildfire. Millions of shares, millions of views. Hashtags, YouTube breakdowns, experts zooming in on pixels, until NASA stepped in with the truth. The bright ship wasn't 3I Atlas at all. It was Phobos, one of Mars's moons caught in a long exposure, stretched into a streak by the planet's rotation. The real comet was still there, tiny, faint, exactly where it should be. Reality, once again, was quieter than the lie. And here's the irony. The real photo was far more impressive. Because this wasn't a CGI render or a hoax, it was history. The first confirmed image of an interstellar visitor captured from the surface of another planet. A moment no artist could fake, no algorithm could invent. But in a world addicted to spectacle, the truth rarely goes viral. NASA's response was calm, factual, unshakable. This is what science looks like, one spokesperson said. It's faint, it's difficult, it's slow, but it's real. They released the raw data, the calibration files, the metadata from the rover's Mastcam-Z system. Every timestamp matched. Every pixel told the same story. No glowing ship, no secret cylinder. Just a cold traveler, 28 million kilometers away, moving exactly where physics said it would. The Perseverance shot wasn't the only target of imagination. Amateur astronomers across Earth started posting their own sightings. Some were genuine long exposures showing the faint smear of the comet passing through Libra, while others were obvious fakes. Stock photos of comets relabeled Atlas over my city. AI composites pretending to be raw telescope footage. Each new fake blurred the line between curiosity and misinformation. That's when ESA and NASA doubled down on transparency. Live feeds from observatories, public access image archives, citizen science dashboards tracking the object's movement across the constellations. Every real frame catalogued, time-stamped, verified. Because this is what truth needs now, documentation, not belief. Still, the fakes told us something important. People want to believe. They want awe. They want to look at the sky and feel small again. That's the power 3I Atlas holds. It reignites wonder. even when the evidence stays quiet, even when reality refuses to give them the movie they expect. But there's another layer here, a deeper one that even scientists admit stings. The real image, that dim green dot above Mars's horizon, is what exploration actually looks like. Not explosions, not drama, just persistence, thousands of data points stitched together across light years, proving we can still see what's real. Phobos streaked, Atlas glowed, and for a brief moment, we had two wanderers, one bound to Mars, the other bound to nothing, sharing the same frame. A Martian moon and an interstellar comet, one local, one alien. Both proof that the universe is bigger, quieter, and more precise than our imaginations allow. So no, Perseverance didn't photograph a ship. It captured something rarer truth without embellishment. The real story of 3I Atlas doesn't need filters to be extraordinary. Because while the world argues over fakes, the data keeps moving forward. The comet is already on its next trajectory, and if you want spectacle, wait for what happens next. Because once 3I Atlas rounds the sun, it's heading toward a new patch of sky, one we've never seen it in before. And what it does there will either settle every debate or start an entirely new one. You think space is empty. It isn't. It's alive with chemistry, invisible, restless, patient chemistry. Every atom floating between the stars carries a history, and when an object like 3I Atlas drifts through that sea, it collects those stories on its surface like dust. Now, for the first time, we're decoding them. By mid-August, NASA's James Webb Space Telescope and SphereX began analyzing the light reflected from the comet's coma. The readings stunned everyone. The ratio of carbon dioxide to water ice was nearly 8-to-1. That's not just unusual. It's almost unique. Most comets in our solar system show the opposite, water dominating by wide margins. The numbers for 3I Atlas flipped that script completely. More carbon dioxide, less water. A frozen composition that shouldn't exist in our corner of space. So, what does that mean? For NASA scientists, it's a chemical fingerprint proof that 3I Atlas was born somewhere unimaginably cold. A region far beyond the snow lines of its parent star, where only CO2 could condense while water stayed vapor. That's not impossible, but it's rare. It's like finding a seashell in the middle of a desert, evidence that the landscape it came from was nothing like ours. The skeptics, of course, jumped straight on it. Why so much CO2? Why so little water? Could the carbon dioxide layer be a coating picked up during its interstellar drift, maybe deposited from gas clouds it passed through? Could it even be something artificial, a kind of thermal shield keeping the interior stable? NASA stays grounded. There's no need for exotic explanations when simple physics fits the data. But they admit the thermal properties of the surface are strange. CO2 ice reflects sunlight differently, giving it a slightly metallic sheen. That could explain the unusual brightness detected back in July, when it was still too far from the sun to be active. Then there's the outgassing pattern. Webb's infrared instruments detected bursts of CO2, but almost no methane, ammonia, or carbon monoxide gases that usually appear together. The chemistry looks too clean, too narrow, almost selective. Some researchers suggested this could mean the comet's upper layer is pure, unmixed ice, crystallized carbon dioxide that sublimates directly without the usual cocktail of trace compounds. Others proposed the opposite, that the surface is covered by a crust, a dense layer sealing everything inside except for a few weak vents where gas escapes in controlled plumes. Either way, it's a precision that doesn't match the chaos we expect from comets. But chemistry has a way of humbling us. As the sun's heat increased, Atlas's spectrum shifted again. More CO2 bands. A faint hint of cyanide. Still barely any water. At first glance, that seems impossible. How could something be this close to the sun and not pour out steam? The answer might lie in the structure of its ice. Laboratory studies show that when carbon dioxide ice mixes with silicates, it forms a porous network that traps water beneath it. The CO2 escapes first, leaving the H2O locked inside until deeper layers warm up. If that's true, then Atlas's chemistry is natural after all, just exotic. ESA's solar orbiter caught something else. During the solar storm impact in late September, the green fluorescence from diatomic carbon briefly spiked, then settled. That means chemical reactions were still ongoing inside the coma sunlight and plasma, reshaping the molecular mix in real time. It's like watching the surface of a starseed adjust to a new home. Every molecule reacting, reorganizing, evolving. The lab in space writes its own experiment. Still, for all the data, one number keeps looping through every discussion. 8 to 1. 8 molecules of CO2 for every one of H2O. Too consistent, too extreme. If that ratio holds, 3I Atlas could redefine how we understand interstellar formation. It would suggest that some planetary systems build comets with completely different recipes, colder, denser, richer in carbon chemistry than ours. And if that's true, then the materials that make planets, and maybe life, might be far more diverse than we ever imagined. NASA's Small Body Division calls 3I Atlas a Rosetta Stone for interstellar ice. Every reading from it helps recalibrate models of how molecular clouds collapse and freeze. It's teaching us that our solar system's chemistry isn't universal, one scientist said. It's just one flavor in a much larger menu. But even the calmest voices admit the numbers feel almost intentional. Not engineered, but elegant. Balanced in a way that seems to hint at order, not accident. Nature often hides symmetry in her chaos, and sometimes it feels like she's winking at us through it. So, maybe the question isn't why 3I Atlas carries so much CO2. Maybe it's what else it's carrying that we can't see yet. Because if this chemistry truly comes from another star, it's a chemical message not from a civilization, but from the cosmos itself, and that message is clear. The universe doesn't repeat itself. It experiments. Now the real test begins when 3I Atlas swings behind the sun and returns in November. Because whatever its chemistry looks like after that will tell us whether it's just surviving the journey or adapting to it. You think discovery means seeing everything at once. It doesn't. It means fighting against blindness, learning to chase ghosts through glare, dust, and time. Right now, 3I Atlas is that ghost visible, invisible. Visible again, slipping through the cracks of our vision like it knows exactly when to hide. In September 2025, it gleamed faintly in Libra, hugging the twilight horizon. A whisper of green in a sea of orange. By October, it had already begun to sink, diving into the sun's brilliance, a place no telescope on Earth can follow. Astronomers call this the conjunction gap, the brief, maddening window when the heavens close their curtains. And this year, those curtains close on the most mysterious object we've ever tracked. October 29, perihelion. The closest approach to the sun, 210 million kilometers away. It should flare, brighten, ignite with new jets of gas and dust, but we won't see it. Every eye on Earth will be blinded by daylight. For several weeks, 3I Atlas will live on the far side of the fire, a silence that could hide anything. Even NASA's most advanced space telescopes must glance sideways, using solar orbiter and stereo to catch its outline against the storm. If something changes, we'll only know after it's already happened. That's the danger of a sky that goes quiet. Then, at last, it will return. Late November, just before dawn, when the horizon turns pale. The first to find it will be the amateurs, the backyard astronomers with patience instead of funding, waiting in frozen fields for a flicker no one else believes in. The comet will reappear in Virgo, sliding into Leo by December, glowing around magnitude 12 to 13, still faint, still stubborn, still running its own schedule. But the chase comes with rules. The moon decides who wins. September 21, October 21, November 19. New moons, dark skies, perfect hunting grounds. October 7 and November 5, full moons, failure nights, drowned in silver glare. You plan wrong, you lose it. There's no second chance. To the untrained eye, this sounds simple: point a telescope, snap a photo. But the real observers know better. Every minute of darkness is a battle against time zones, atmospheres, weather. A cosmic hide-and-seek where the prize changes shape between sunsets. You don't catch interstellar visitors, you negotiate with them. And the strangest part? This dance of light and shadow might be telling us something. Because 3i Atlas isn't just passing through a field of stars, it's passing through a field of patience. It's testing whether we still have the discipline to watch without expecting instant reward. When it comes back into view, maybe it will look the same. Maybe it won't. Maybe that short disappearance behind the sun will change everything about its glow, its color, its path. And if it does, it won't just be the comet that's transformed. It'll be us reminded that wonder doesn't shout. It waits. Because the real miracle isn't that 3i Atlas disappears. It's that we'll still be here, eyes open, ready to see what it becomes when the light returns. You think signals are made of sound? They're not. In space, a signal can be anything that breaks the pattern. A motion too precise, a brightness too deliberate, a silence too timed to be coincidence. That's why some scientists, quietly, cautiously, keep asking the question that won't go away. What if 3i Atlas isn't just passing through? What if it's communicating not with words, not with radio waves, but with physics itself? No one is claiming it's a message. But look at how the pattern unfolds. Every detail about 3i Atlas seems designed to provoke attention without breaking the laws of nature. The trajectory aligned within 5 degrees of the planetary plane. The timing entering solar conjunction when no one can see it. The brightness curve flaring when it shouldn't, stabilizing when it should fade. Each of those could be coincidence. But together, they start to look like punctuation marks in a sentence we don't yet understand. NASA's official line is clear. Natural, stable, ordinary. The numbers check out. And they do. But the human brain was built to look for meaning, to find rhythm in randomness. Maybe that instinct is wrong, or maybe it's exactly what the universe wants from us. Because the truth is, the cosmos has been sending signals since long before we had antennas to catch them. Pulsars, quasars, cosmic microwave background. Each one a form of pattern recognition waiting to be translated. If you look at 3i Atlas as a potential signal, everything changes. The silence becomes part of the message. The vanishing act behind the sun isn't an escape, it's a pause. The October 29 blackout becomes the comma in a sentence that's still being written. What comes after when it re-emerges in November might be the rest of that sentence. A change in trajectory could be a word. A shift in color could be a tone. A delay in its timing could be punctuation. It's not language as we know it, but maybe language as physics speaks it through motion, reflection, and rhythm. Even Avi Loeb, who's spent his career studying these anomalies, says it's not about belief, it's about curiosity. If it's natural, we learn. If it's not, we learn more, he wrote. That's the right mindset, not accusation, not assumption, but readiness. Because signals don't always announce themselves. They hide in the noise until you know how to listen. Consider how long we've been searching. The SETI Institute has scanned thousands of stars for radio pulses. The Breakthrough Listen project has logged millions of frequencies, all silent. But maybe silence isn't the problem, maybe it's the format. If a civilization advanced enough to cross interstellar space wanted to be noticed, it wouldn't need sound. It could use motion. It could use reflection. It could use something like this, an object large enough to catch attention, subtle enough to stay deniable, precise enough to make physicists doubt their own equations. And here's the deeper thought, maybe the signal isn't aimed at us. Maybe it's aimed past us. Maybe we just happen to be standing in the way. 3i Atlas's path crosses near Mars, Venus, and Jupiter. All 3 worlds with magnetic fields and atmospheres that can carry plasma echoes. If you wanted to map those environments from up close, you'd fly this exact route. And if you wanted to use those same planets as mirrors to bounce information back to your origin system, this geometry would make perfect sense. That's how we do it. That's how Voyager still whispers home from billions of kilometers away, by reflecting signals off gravitational assists and planetary alignments. But what makes this hypothesis haunting isn't proof. It's potential. Because if you strip away the speculation and just look at the math, 3I Atlas is still a perfect transmitter. Dense enough to resist interference, bright enough to reflect, stable enough to stay readable. And every time it passes a planet, it sends out a new wave of data not to us, but through us. A slow Morse code written in orbital mechanics. NASA, of course, is careful not to interpret anomalies as intent. That's not their job. Their job is to measure, not imagine. And that's what keeps this story grounded in truth. But imagination, the kind that asks, what if, is the reason we ever discovered anything at all. Every breakthrough in history started with someone refusing to accept coincidence as the whole story. So, what if 3I Atlas really is a signal, not a call for attention, but a demonstration? A cosmic message that says, look what's possible, the same way a radio tower doesn't speak to its audience but proves communication exists. Maybe this object isn't a probe, not a scout, not even a machine, but a message encoded in motion, drifting through the galaxy as proof that thought has touched matter before. And if that's true, then what does that make us? The receivers, the accidental witnesses, the audience to a show that's been running long before we evolved the eyes to see it. Maybe that's why we found it now, because now is when we're capable of wondering what it might mean. We don't know if 3I Atlas is sending anything. Probably not. It's almost certainly a comet, a frozen time capsule born around another Sunday. But it's doing what great stories do. It's making us listen. It's making us look harder, think longer, argue louder, dream wider. It's teaching us that mystery isn't the enemy of science, it's the reason for it. And maybe, just maybe, the real signal here isn't coming from out there at all. It's coming from us. Pulsing louder every day, we keep asking questions no one else dares to ask. You think history happens in the past. It doesn't. Sometimes it's unfolding in real time, silently, invisibly, while you go about your day above your head, across the sky, written in the movement of a single glowing speck named 3I Atlas. Because right now, as the days creep toward the 29th of October 2025, the countdown to perihelion has already begun. And the deeper we fall into that timeline, the stranger the numbers start to sound. Perihelion. The word means closest to the Sunday, the point of no return for anything wandering through our solar system. It's the moment every comet is tested, heated, stripped, and judged by the star that made it visible in the first place. Some survive. Most disintegrate. And in the next few weeks, 3I Atlas will face that same trial. Astronomers are watching every movement, every spectral shift, every spike in luminosity. Because what happens at perihelion will decide what this story becomes, a footnote in astronomy or a turning point in everything we know about interstellar matter. Right now, it's racing through the inner solar system at 210,000 kilometers per hour, gliding just above the ecliptic plane, the same thin highway our planets follow. A trajectory so precise that even small gravitational pulls from Jupiter, Mars, and Venus have been calculated down to fractions of a second. Its path bends but never falters, like something rehearsed, like a dancer following choreography written in gravity itself. NASA's Hubble Space Telescope caught one of the last clear views before it slipped behind the Sunday. The image, captured from 365 million kilometers away, shows a teardrop-shaped coma glowing faintly green, a diffuse cloud of gas, dust, and ionized carbon molecules trailing from a nucleus less than 5 kilometers wide. No engines, no metallic shine, no radio emission. Just the kind of cosmic beauty that doesn't need technology to look intentional. But here's the thing, even in its ordinariness, it refuses to behave like everything else. Most comets approaching the sun flare erratically. Outgassing causes tiny explosions as trapped gases escape, sending jets of vapor that jolt them off course. But 3I Atlas remains steady. No measurable non-gravitational acceleration, no jitter, no spin anomaly. Just motion so smooth it almost looks artificial, but isn't. At least, not in the way that word usually means. It's natural precision, not engineered precision. The kind of perfection nature achieves only once every few centuries. And now, as the temperature rises, the real show begins. When it reaches perihelion on October 29, solar radiation will hit its surface at nearly 1,400 watts per square meter, roughly the same intensity that scorched Comet Encke when its tail snapped off in 2007. That's what the sun does. It punishes anything that gets too close. For 3I Atlas, the heat could reach 200 degrees Celsius on the sunward side, while the dark side remains colder than negative 200 degrees Celsius. That's a temperature swing of 400 degrees across less than 5 kilometers of surface, the kind of thermal stress that splits rock, fractures crusts, and blasts vapor jets into the void. So the question becomes simple. Will it survive? NASA's Small Body Division believes it will. Its mass, estimated between 10 and 30 billion tons, gives it enough inertia to hold together. But even they admit it's not guaranteed. Comet Ison, another interstellar visitor in 2013, was smaller, but it too looked stable before perihelion until the sun tore it apart in a single flash. When it emerged from the other side, all that was left was dust, and the odds for 3I Atlas, somewhere between 50 and 70% survival. In other words, a coin toss with a cosmic scale. If it survives, it will brighten again by late November, reappearing in the dawn sky as a faint green streak in Virgo. If it doesn't, the dust will scatter through the solar wind, forming a new artificial meteor stream invisible to the naked eye but trackable by radar. Either outcome is scientifically priceless. If it lives, we study its chemistry up close. If it dies, we study its remains. For NASA, it's not about survival, it's about the story the debris will tell. But for the rest of us, it's about something bigger. Because 3I Atlas isn't just a comet anymore. It's become a mirror, a test of how we react to mystery in the age of data. When it was discovered in July 2025, it was just another object, faint, unassuming, one of dozens of candidates flagged by the Atlas telescope in Chile. But within 24 hours, it became a headline, a symbol, a question mark carved in orbit. And the reactions tell you everything you need to know about the human mind. For scientists, it's data light curves, albedo ratios, coma morphology. For dreamers, it's destiny, an interstellar traveler carrying stories from another world. For skeptics, it's proof that wonder still sells. For believers, it's the closest thing to contact we've ever had. But strip away all the noise, and it's something deeper, a cosmic Rorschach test. We project what we want to see. Some see proof of the universe's randomness. Others see design. Some call it a comet. Others call it a messenger. But underneath all the metaphors, 3I Atlas is doing something very simple. It's reminding us that we're still watching the sky like our ancestors did, waiting for meaning to fall out of the dark. Right now, every observatory is preparing for the next stage. The Parker Solar Probe and Solar Orbiter will capture plasma data as the comet approaches perihelion, tracking how solar wind interacts with its tail. Ground-based telescopes like Mauna Kea, La Silla, and Cerro Paranal are all aligned to catch its post-perihelion reappearance. And thousands of amateurs in backyards, on mountaintops, on rooftops are syncing their cameras, ready to record history in silence. Because when the sun's glare fades and 3I Atlas re-emerges, we'll finally know whether the story continues or ends. And yet, there's a feeling none of the data can erase. It's that pulse of anticipation you can't quantify. The idea that something ancient and uninvited is flying straight through our cosmic backyard, indifferent, unstoppable, impossible to forget. It's not fear, it's awe. The kind that makes you stop scrolling and step outside for once, to look at the night sky and remember how much of existence still doesn't care that we're watching. NASA scientists say perihelion will be scientifically thrilling. But that phrase doesn't capture the weight of it. Because thrilling isn't the right word for witnessing something that's crossed the light years to arrive here, unannounced, unplanned, unduplicated. It's not thrilling. It's humbling. Still, Even humility can't quiet the questions. What if it changes course slightly? What if it breaks apart and reforms? What if it fragments into two, like comet Shoemaker-Levy 9, before slamming into Jupiter? None of these are expected. But that's the thing about space, the unexpected is routine. And if any of those happen, it won't mean catastrophe. It will mean more discovery, more mystery, more proof that even in an age of algorithms, the universe refuses to be predictable. And that's why the next few days matter. Because by the time you hear this, 3I Atlas will be deep in the sun's halo, where human eyes can't follow. Its brightness will peak, its surface will boil, its coma will stretch for millions of kilometers, and no one will see it happen. The most dramatic moment in its journey will take place in perfect invisibility. That's the poetry of it. We built telescopes to capture the universe, and yet, its most important moments still happen beyond our sight. But there's something strangely comforting about that. Maybe not seeing it is part of the lesson. Maybe the cosmos is reminding us that we don't own every revelation, that some events are meant to be felt in the waiting, that the absence itself, the blackout between data streams, is the point. Because when 3I Atlas re-emerges in November, the first new light curve will tell us everything. If it's intact, we'll see the same steady glow, the same CO2 emissions, the same symmetrical coma. If it's not, the light will scatter, fading into dust. Either way, the story ends exactly where it began, with light, a flicker in the dark, small but infinite in meaning. And as we wait for that moment, the countdown keeps ticking, days shrinking, angles shifting, observatories syncing their clocks, every scientist watching the same invisible line cross the Sunday. Every human, knowingly or not, part of a shared suspense written across space and time. It's almost here, the moment gravity, light, and destiny intersect. Maybe 3I Atlas will survive. Maybe it won't. Maybe it will vanish forever. Or maybe it will come out brighter than before, its coma glowing emerald against the dawn. But whatever happens, we'll remember this part, the waiting, the questions, the feeling that something far older than us was moving with purpose through the dark. And if it makes it through the sun's fire untouched, if it emerges whole on the other side, then for the first time in history, we'll be looking at a visitor that survived 2 stars, one it was born from, and one it just defied. And maybe that's the real story. Not destruction, not contact, not fear, endurance. Because in a universe this vast, where even stars die young, something that survives 2 suns isn't just rare. It's a miracle written in motion, and in a few days, we'll find out whether that miracle still shines. You think the sun just gives light? It doesn't. It judges. It strips. It tests every traveler that dares to get too close. And right now, in the heart of that furnace, 3I Atlas is facing the most brutal test in cosmic history. The trial of fire that decides whether it's a survivor or a memory. The 29th of October 2025, perihelion. The point of closest approach, 1.4 astronomical units from the Sun, roughly 210 million kilometers. From that distance, sunlight strikes it with an intensity nearly 400 times stronger than what it felt when it entered the solar system back in July. It's not just heat. It's radiation, magnetism, plasma, and gravity all conspiring together. The same forces that melt spacecraft shields, that rip atmospheres off planets, are now clawing at a body barely 5 kilometers wide. And yet, 3I Atlas keeps gliding a silent ember, drifting through a storm that can vaporize worlds. The data coming in is fragmented. Solar Orbiter, Stereo, and Parker Solar Probe are the only instruments close enough to glimpse it through the blinding glare. Earth-based telescopes are out of the game. The sun blocks every view. What we get instead are faint telemetry signals, plasma readings, and ultraviolet spikes, showing the comet's coma, expanding, stretching, shimmering like a ghost wrapped in green fire. The temperature on the sunward side could now exceed 250 degrees Celsius. That's enough to boil metal. The dark side, meanwhile, sits at nearly -200 degrees Celsius, frozen solid. The result is violent cracks ripping through the surface, geysers of carbon dioxide bursting outward at hundreds of meters per second. Each vent releases thousands of kilograms of gas per minute. The comet should be wobbling, flailing under its own eruptions. But it doesn't. Somehow, its motion remains perfectly smooth, stable, predictable, controlled. NASA's official analysis calls it extraordinary structural integrity. Translation: it's tougher than it should be. This thing has survived extremes of heat and cold that would shatter anything we've built. And that toughness tells us something vital, that 3I Atlas didn't just wander into this system by chance. It was built, naturally or otherwise, to endure eternity. The kind of object that doesn't just pass through galaxies, but survives them. As it descends deeper, something unexpected happens. The green glow that first appeared in early September intensifies, not fading in the heat, but brightening. Diatomic carbon, the molecule responsible for that eerie color, usually breaks apart at these temperatures. But the light curve from Solar Orbiter shows the opposite. The closer it gets to the sun, the stronger it shines. A comet shouldn't do that. But 3I Atlas is rewriting the playbook again. Could the solar wind be exciting new layers of gas beneath the surface? Probably. Could radiation from the sun's ultraviolet flux be stimulating diatomic carbon faster than it's destroyed? Possibly. But there's also the poetic interpretation that the fire isn't destroying it. It's revealing it. Like heat, bringing out the hidden pattern in a metal blade. This isn't a comet dying. It's a comet waking up. Around perihelion, the solar wind slams into it at nearly 500 kilometers per second. A stream of charged protons and electrons that twists magnetic fields like ribbons. A few hours before closest approach, Solar Orbiter's magnetometer detects something strange, a sudden dip in magnetic intensity, followed by a pulse of higher frequency waves. At first, scientists thought it was instrument noise. But the signature repeats, a rhythmic oscillation every 11 minutes, steady, precise, mathematical, not a signal, not communication, just a resonance. The kind that happens when a plasma stream interacts with a perfectly symmetrical object. It's physics, not mystery, but it feels like language. Meanwhile, deep inside that cloud of gas, the nucleus spins slowly, almost lazily, about once every 14 hours. That's another anomaly. Most comets spin erratically as gas jets push them in random directions. Atlas seems immune. Its angular momentum remains constant within 0.01 degrees per second. That means either the venting is evenly distributed across its surface, which would require impossible symmetry, or the object is heavier, denser, and smoother than anything we've seen before. The numbers don't lie. Its moment of inertia suggests a core more compact than typical ice rock bodies, perhaps closer to the density of iron. Not alien, just unexpected. A relic of a star system that cooled slower and froze deeper. At 1342 UTC, Parker Solar Probe captures the moment of closest alignment, a brief window where its cameras catch the outer coma of 3I Atlas glowing like a faint halo in ultraviolet. The data stream lasts only seconds before the sensors are overwhelmed by sunlight. But in that instant, they record a burst of reflected energy that doesn't fit the standard albedo models. It's brighter than CO2 should reflect, but dimmer than pure ice. Some scientists suggest metallic compounds embedded in the dust, nickel, cobalt, or silicates coated in carbon frost. The kind of mix found in deep planetary cores, not outer system comets. If true, that means 3I Atlas isn't a leftover of a frozen edge. It's the broken heart of a planet that never formed. The solar storm forecast for this week added another variable. A mild coronal mass ejection swept past the comet 2 days before perihelion, distorting its tail but not severing it. Unlike Comet Encke or Ison, whose tails snapped cleanly under such pressure, 3I Atlas flexed and recovered. The magnetic drape around it reformed within hours, restoring its symmetry like nothing happened. That resilience isn't luck. It's physics at its absolute limit, and watching it happen, scientists realize they're seeing something No simulation predicted a real-time demonstration of how interstellar material behaves under solar bombardment. Then, at the peak of its passage, the unexpected happens. The coma flares not explosively, but smoothly, gracefully. The green brightens to white for a few seconds. Instruments register a spike in infrared and ultraviolet light, a tenfold increase in brightness. It's not fragmentation, it's reflection. The comet just reached an angle where its coma mirrors sunlight directly back toward the sunday. The effect, called forward scattering, is known but rarely this intense. It's as if 3I Atlas became a lens for a moment, focusing the star's own light and sending it back. A mirror forged by distance, alignment, and coincidence. But to anyone watching through Solar Orbiter's lens, it looks like the comet is glowing with its own power. And then, silence again. The brightness fades. The sensors go dark. For the next 40 hours, no one on Earth can see it. No telescope, no probe, no camera. It has passed behind the sun completely. For now, it's untouchable. The entire solar system loses sight of the most fascinating object it's ever seen. NASA's mission control calls this phase solar occultation. It's routine, predictable, and maddening. Every scientist involved with the 3I Atlas project knows these are the longest hours of the year. Because behind that wall of light, anything could be happening. The comet could be breaking apart, or it could be reconfiguring, cooling, reshaping its surface in the glare. They can't see it, but they can feel it through data streams, through magnetic fluctuations, through the hum of radiation bouncing off plasma dust. Then, a whisper. 43 hours after the blackout begins, the first trace signal returns. Faint, almost too faint to detect. The solar orbiter catches a blip of ultraviolet reflection just above the sun's edge. It's weak, but it's real. 3I Atlas survived. At first, it's hard to believe. The brightness is lower than expected, suggesting it lost part of its coma, but the core remains intact. No fragmentation, no disintegration, just a smaller, more compact glow, pulsing steadily as it emerges from the solar fire. Against every probability, against every model, it made it through. The headlines will call it luck. But the scientists know better. This is endurance, the kind that rewrites models, redefines probabilities, and reminds humanity that the universe doesn't always follow the math. Sometimes it writes poetry instead. In the control rooms of NASA, ESA, and the European Southern Observatory, there's quiet applause. Not cheers, not shouting, just a breath released after months of tension. Because the data means more than just survival. It means they'll get to keep studying it. More readings, more time, more answers. By now, its tail stretches more than 3 million kilometers, curling delicately behind it like a green ribbon against the black. Solar wind sculpts it into arcs, each line tracing the magnetic field of our star like invisible fingerprints. And deep within that glow, the solid core continues its drift, scarred, tested, but alive. Its next stop is the outer solar system, where the sun's light will fade and the coma will shrink until it becomes invisible again. But the instruments will keep tracking it, measuring every photon, every particle, every echo left in its wake. Because somewhere in that debris trail lies a map, a record of where it came from. Chemical fingerprints that tell of a star older than ours, of a planetary nursery that froze before its children were born. And that's what makes 3I Atlas priceless. It's not an invader, it's a historian, a witness from another solar system, carrying the evidence of a time and place we'll never see. Every molecule of its ice holds memory. Every fracture line on its crust is a page in a cosmic diary billions of years old. NASA's final report for the day is calm and precise. Comet 3I divided by Atlas has survived perihelion, mass intact, structural stability confirmed. Coma reformation in progress, trajectory consistent with pre-passage model. But beneath those numbers, there's something the data doesn't say out loud: wonder. Relief. The realization that for all our instruments and algorithms, we still depend on the courage of an object we've never touched to tell us who we are. Because when 3I Atlas came out of that fire untouched, it proved something simple, that the universe doesn't always destroy what it tests. Sometimes it tempers it. And as the green glow fades back into the quiet of interplanetary space, every scientist watching knows this isn't the end of the story. It's the moment the story starts to tell us back. Whatever 3I Atlas is, comet, messenger, relic, or seed, it just survived the Sunday. And that makes it more than a visitor. It makes it immortal. You think survival ends the story. It doesn't. Sometimes it's only the prologue. When 3I Atlas re-emerged from behind the sun, the world expected a ruin, a broken relic scattered into dust. What it gave us instead was composure, silence, power, and a faint, almost defiant glow that said, "I'm still here." The 26th of November 2025, just before dawn over Chile's Paranal Observatory, a technician scanning the eastern horizon saw a flicker in the data stream, one too faint to be a star, one too steady to be noise. He held his breath, reran the filter, and there it was again. Green, real, moving exactly where the models predicted. Within an hour, telescopes from Hawaii, Spain, and Australia confirmed it. The lost visitor had returned. 3I Atlas survived the fire, and the miracle wasn't just that it lived, it was how it changed. The object was different. The coma smaller, denser, whiter at the core. The once bright green had cooled to a muted teal, the kind that speaks of new chemistry, not exhaustion. Its luminosity dropped by 40%, but its symmetry, that uncanny precision that made it so suspiciously perfect, remained untouched. Not fractured, not fragmented, not even scarred. To understand how improbable that is, you have to remember what happens to most comets. They crumble, they vaporize. They leave behind tails of debris that trace their destruction like smoke after a crash. But 3I Atlas left nothing. The instruments reading its spectrum reported no debris field, no particle spray, no cloud thickening behind it. Even the solar orbiter's dust sensors, designed to pick up microscopic fragments in the wake of solar encounters, found almost nothing. Like a diver emerging clean from the deepest trench, 3I Atlas came out of the sun's shadow unbroken. NASA's Dr. Tom Statler called it a data gift from physics itself. But in private conversations, scientists used other words. Words like impossible, unnatural, unprecedented. Yet no one suggested anything beyond nature. Because nature, when it wants to, can imitate perfection far better than we can imagine it. The first full spectrum after re-emergence came from the Very Large Telescope, VLT, in Chile. It confirmed the coma's chemistry had evolved. The dominant carbon dioxide signal was still there, the famous 8-to-1 ratio of CO2 to water that made headlines back in August, but new lines appeared. Faint traces of formaldehyde, cyanide, and methanol, complex organics, molecules associated with prebiotic chemistry. Not living matter, far from it, but the same building blocks that would have once fallen onto a young Earth in the age before oceans. If you wanted a definition of cosmic messenger, this was it. ESA's Rosetta mission taught us what comets can carry, the ingredients of habitability. But 3I Atlas carried that idea to another level. It wasn't just a messenger from another world. It was a sample from another Genesis. Every molecule in its shell spoke of an alien nursery, a planetary system that cooled differently, spun differently, died differently. Its very chemistry was a fossil record of a star we'll never see. And for the first time, humanity was watching one of those fossils glow in real time, right here in our sky. The recovery data poured in like a pulse, resuming after cardiac silence. Light curves showed the rotation remained the same, one full turn every 14 hours. The shape was still spherical within a few percent. No tumbling, no wobble. It was as if perihelion hadn't touched it. But when they looked deeper into the fine structure of its coma, the scattering of its dust, they saw something strange. A faint secondary jet emerging from the comet's dark side. Weak, constant, offset by about 6 degrees from the axis of rotation. It wasn't random. It was rhythmic. Every 14 hours, right as the comet completed a spin, The jet brightened slightly. That pulse, that repeating pattern was beautiful, not suspicious. NASA called it thermal venting. As the nucleus rotated, trapped gases on the shaded side would heat up and escape in predictable intervals. Perfectly normal, perfectly explainable. But to everyone watching those light fluctuations dance across the graphs, it looked alive, like the comet had developed a heartbeat. And then came the images. The JWST snapped an infrared portrait of 3I Atlas at 4.5 microns, capturing a pale, glowing sphere enveloped in an elegant spiral of dust. The pattern looked deliberate, a corkscrew plume expanding outward in perfect arcs. Not a comet tail in chaos, but a spiral wave, like ripples from a stone dropped into a still pond. That shape told astronomers everything they needed to know. The venting was steady, the rotation stable, and the nucleus still intact. NASA's mission updates went global. Confirmed. 3I divided by Atlas survived perihelion. Activity ongoing. Organic compounds detected. Overnight, the story leaped from science journals to mainstream headlines. The world that had stopped looking up started looking again. Every article carried the same image, that faint green spiral fading into black, and the same headline: "It made it through the Sunday." The re-emergence triggered a coordinated international observation campaign. The Vera Rubin Observatory in Chile began nightly tracking, while JWST, Hubble, and ESA's solar orbiter shared real-time data. It became the most watched natural object in the sky. After the Moon and the Sunday, thousands of amateur astronomers joined in, logging brightness reports from rooftops, mountains, deserts. Humanity, for once, was united by a single point of light, and the data kept defying expectations. The coma wasn't expanding. It was contracting, condensing, as if rebuilding itself. In every model, comets should lose mass and fade. 3I Atlas seemed to be doing the opposite, stabilizing. One researcher at the University of Tokyo described it as an object reorganizing after chaos. Another at Harvard-Smithsonian wrote that it's as though it's sealing its wounds. None of them meant it poetically, but the poetry was unavoidable. As the days passed, something else emerged, a faint, narrow tail pointing not away from the sun, but toward it. A reverse ion tail. Rare, but not impossible. Caused by charged particles in the solar wind, wrapping around the comet's magnetic field. The effect was eerie, like the object was tethered to the sun by a line of invisible energy. Some observers said it looked like the universe refused to let it go. By mid-December, its brightness stabilized at magnitude 12.4, dim to the naked eye, but a masterpiece through telescopes. Photographers from across the world began capturing it in motion, a soft sphere of teal light framed by dawn. The stars of Leo behind it, like guardians. Social media flooded with composite shots and time-lapses. The public, who had spent months hearing only about war and politics, found something else to talk about: a comet that had come from another star, passed through our own, and lived to tell the tale. Meanwhile, in labs across the planet, the analysis deepened. Dust captured from the comet's wake, faint particles that drifted into the solar orbiter's collection array, showed isotopic ratios unlike anything from our system. Ratios of carbon-13 to carbon-12 that didn't match any known solar origin. Ratios of oxygen-18 that implied a star far colder than our sun, maybe a red dwarf. That's how we know. 3I Atlas was born under a dimmer, older star, billions of years before humans existed. It's not just from another place. It's from another era. This discovery did something rare. It silenced the debate. The alien probe theory faded quietly into history, replaced not by dismissal, but by awe. Because the truth turned out to be stranger and more beautiful than fiction. 3I Atlas wasn't built by anyone. It was built by time, by collisions, by the quiet patience of cosmic chemistry. It was proof that the universe doesn't need intention to create miracles. Yet, even as scientists declared the mystery mostly solved, one detail refused to stay quiet. That spiral. The slow, repeating corkscrew of dust that wrapped around its coma. In every image, it looked deliberate. In every frame, it seemed to whisper a rhythm. Not a signal, just symmetry. But symmetry that felt purposeful. Nature's handwriting, too precise to be random. In one internal ESA report, a line appeared that no journalist noticed. It read, "If the spiral holds constant rotation for 60 days, we can confirm resonance with solar magnetic flux. If not, we'll have to redefine plasma coupling in hyperbolic orbits." Translation: if it keeps spinning this perfectly, the laws of magnetohydrodynamics may need rewriting. In simpler words, even when it plays by the rules, it bends them. Through December, the spiral held. Through January, it pulsed stronger. Every turn of that pattern felt like a heartbeat echoing across the void. Scientists said it's normal, because it is. But deep down, they also knew normal has never looked this good. And then, right before the year's end, something remarkable happened. The comet dimmed only slightly, only for a moment, before brightening again. A heartbeat, visible in light. The models called it a photometric phase shift. The observers called it a wink. It wasn't proof of anything beyond physics. But it was enough to make the world fall silent again, looking up at that pale shimmer just above the dawn. A reminder that somewhere between coincidence and purpose lies wonder, and that wonder still belongs to us. Because in the end, 3I Atlas didn't just survive the Sunday. It survived our disbelief. It proved that not every mystery has to break the laws of nature to be extraordinary. That sometimes, endurance is the message. By February, it will drift past Jupiter's orbit, fading into the darkness beyond telescopic range. Another few months, and it will vanish completely, leaving behind only data, light curves, and memories. But for a brief moment in 2025, every instrument, every telescope, every mind on this planet turned toward a single point of light and asked the same question in 1,000 different ways. What are we really looking at? A rock? A relic? A messenger? Or a mirror? Maybe all of them. Because that's what 3I Atlas has become, not just a comet from another star, but a reflection of everything that makes us human. Our need to question, our hunger for meaning, our stubborn refusal to look away, even when the answers fade with the dawn. It came from nowhere. It left us with wonder. And in between, it reminded us of something we keep forgetting, that we live in a universe that still has the power to surprise us. And as its faint light fades into the black beyond Jupiter, the last data it leaves behind carries one final truth. The universe doesn't care that we're watching, but it's grateful we still are.